brisker rate and those trailing farther out in their cyclic rounds. Like leaves blown across an autumn forest floor in circular motions, but each following separate paths, so too do these luminous leaves follow in the wind of their orb as the unseen tide of dark matter pulls them in repeated journeys. A kinship exists between these neighboring stars that share similar generations yet voyages entirely alone. Some started their lives together in a bustling stellar nursery before being scattered across this corner of the Orion arm as the gas cloud dissipated. Until now, drifting suns once seen as lone wanderers found each other anew. Others reached this sector of the galaxy by more solitary means, joining the parade of a billion singular celestial wanderers in their graceful pavane around the galactic core. Each member holds their own intimate history to divulge under scrutiny, like individual droplets in a great sea of many, individual triumphs and tragedies unfolding across the scope of time itself. Of all the black holes and other objects, profound mysteries that human knowledge seeks to uncover, none compare to grasping the utterly incomprehensible beginning of everything in the cosmic dawn. Through ingenious observation and theory building, physics has managed to reconstruct the history of the universe back to the briefest sliver of a second after its birth in the Big Bang almost 14 billion years ago. But the exact origin itself and what may have preceded it remain shrouded in impenetrable uncertainty, posing the ultimate challenge to science and imagination. The observational pillar supporting the Big Bang model arises from the clear expansion seen in the universe on the largest scales, implying everything emerged from a hot dense state in the distant past. But extrapolating backward, the expansion suggests an initial point of infinite density that physics cannot meaningfully describe. All our theories break down irreconcilably when stretched to their primordial singularity. The beginning appears forever out of reach. Attempts like the bouncing cosmology theory tried to. The Milky Way galaxy has fascinated humanity since earliest times when our ancestors gazed upon the river of light stretching across the night sky. Unknown to them, this band of stars, which we now know as the Milky Way, represents the spiral disk of hundreds of billions of stars where our own solar system resides. Though difficult to perceive from within due to being embedded within the swirling sea of stars, advances in tools used for astronomy have enabled us to learn about our galaxy's overall structure. From the central ball dominating its inner regions to the spherical skin encapsulating it and remnants of smaller galaxies that have been absorbed during its lifetime of over 13 billion annual revolutions around the celestial sphere, stretching over 100,000 light-years into the immense Milky Way stands taller than the distance between any two terrestrial kingdoms on Earth. Its spiral arms, curled around the core region, resemble the tendrils of a colossal celestial vine snaking their way through the star-through void. Bright young stars still in the earliest phases of stellar evolution sparkle blue among the brightly glowing clouds of gas and dust from which they recently formed. While older populations of yellow, orange, and red stars drift in the spaces between their nuclear furnaces, entering advanced stages of fusion after billions of years of converting hydrogen into helium deep within massive, beyond terrestrial comprehension. An estimated 300 billion stars. The Milky Way provides habitat not only for our Sun and its planets but entire generations of stellar families across its broad stellar disk. Among these stars are some which have ended their lives in violet supernova explosions, scattering the calcium in our bones, the iron in our blood, and other elements throughout the galaxy to be trapped in new stars and planets. It is this continual recycling of stardust across deep time that allowed life as we know it, from the first microbes to thinking beings now pondering their cosmic address, to evolve on our planet third from the Sun. Truly, we are the children of the Milky Way. The structure and composition of the Milky Way contain numerous constituent parts that collectively give it form and structure. Its central mass is known as the bulge, a tightly packed congregation of stars forming an oval framework spanning numerous light-years. Across here, hundreds of millions of stars jostle in close company with little room between. Their great density and high speeds of motion generate intense gravitational tides that regularly wrench some from orbit, casting them freely into the remote stellar wilderness. Beyond surrounding this tight core lies the disk of our galaxy itself, a swirling platter some 100,000 light-years in diameter within which two grand spiraling arms wind their gaseous ribbons. These are the home to spectacular stellar nurseries where newborn stars still dressed in their natal shrouds of glowing gas and dust first taste fusion's fire. Between these fertile grounds sail older populations of stars carrying various hues from the blazing blue-white of the youngest to the dimmed ember glow of the most aged. Many such stars, once like our gentle yellow sun, now lay cold and dark, having exhausted their primary supply of light elements in nuclear reactions billions of years past. Further still, emerging from the darkness like a great shadow, is the extended spiral halo encompassing all. Here flowed ancient stars dating to the infancy of the universe, their origins perhaps lying in smaller galaxies that at some point in the deep past came too near the bigger behemoth that is the Milky Way and lost their individual identities. Wrapped in low light on the celestial frontiers, these are stellar relics providing clues to the galaxy's formative years. Truly, each part contributes its story so that together a vivid portrait takes shape of the magnificent island universe we are privileged to call home. The Milky Way's spiral arms are identified as the Scutum Centaurus arm, the Sagittarian arm, the Perseus arm, and the Kinina Sagittarius arm. These are sites of ongoing and new star formation, populated with clouds of gas and dust in addition to stars of various ages and stages. The galaxy is filled with nebulae, vast diffused clouds of gas, dust, and plasma. Iconic regions like the Orion Nebula reveal stars in the earliest phases of formation. It's estimated the Milky Way collided with a smaller galaxy about 10 billion years ago. The effects of this interaction led to perturbations that triggered new bursts of star birth over billions of years. Although a spiral galaxy, observations also indicate the presence of an old elliptical halo of stars wrapping around the edges like a giant spherical cloak. Our solar system presides within the Orion Spur, a minor spiral arm in the galaxy's outer disk about 2/3 of the way to the rim. Ongoing studies of the Milky Way's composition and dynamics continue to provide new insights into how galaxies evolve over cosmic time. Among the greatest revelations to emerge from persistent astronomical observation is a deeper comprehension of our place within the Milky Way. With improved instrumentation allowing the distinction of finer details across the reaches of the galaxy, scientists are gaining new perspective on our vocation relative to this gigantic conglomeration of stars. It has been determined that our Sun and its retinue of planets, including Earth, orbit near an outer spiral arm of the galactic disk, approximately 2/3 of the distance from the brilliant core to the dim outer frontier. This arm, called the Orion Spur, by some early sky watchers due to its location hosting those constellations, winds a meandering path through the starry sea and is fertile in stellar nurseries. From our vantage point, the sky appears ablaze with the overlapping glow of many such stellar generational groups. In the direction of the galactic center, our solar neighborhood meanwhile hosts but a few striving stars, evidence we dwell away from the most prodigious star-forming regions. Each annual revolution around the massive galactic core takes approximately 230 million days to complete, a stately processional pace even compared against geological change on Earth. Our Sun's journey is one shared by many others in an undulation motion echoing the grand spiral structure that is visible when viewing other galaxies edge-on. In this way, we circle over vast distances yet remain in company with the same billion stars that make up this small part of one arm. Countless more lie unseen in other spiral filaments and the inner zones at the edge of comprehension, all together united yet apart in existence as a single celestial island populated by the heaven's light. Such knowledge enhances one's connection to a grander whole and our own impermanence in the face of such immense celestial architecture. With insights into the Milky Way's composition and structure as context, ongoing inquiries work to further elucidate the details of our stellar neighborhood and solar system's precise journey around the massive galactic core. Though our advantage remains fixed aboard Earth and her moon, technological instruments now serve to peer more deeply into the surrounding star sea. Spectroscopic analysis of nearby stars has revealed much about their chemical histories and ages through signatures in the wavelengths of light emitted. In this way, in our stellar family and even more distant denizens, have started to give up their formation narratives across unthinkable epochs of time. It is found that the Sun is relatively youthful at roughly 4,700,000,000 annual revolutions old, compared to certain stars over twice that age, drifting in remote districts. Other local stars closely resemble our own in elemental percentage, while some appear enriched or diminished in metals forged through generations of media years inside earlier generations of long-deceased stars. All circle the galactic nucleus at different paces as well, with our neighborhood hosting members both circling at brisker rate and those trailing farther out in their cyclic rounds. Like leaves blown across an autumn forest floor in circular motions, but each following separate paths, so too do these luminous leaves follow in the wind of their orb as the unseen tide of dark matter pulls them in repeated journeys. A kinship exists between these neighboring stars that share similar generations yet voyages entirely alone. Some started their lives together in a bustling stellar nursery before being scattered across this corner of the Orion arm as the gas cloud dissipated. Until now, drifting suns once seen as lone wanderers found each other anew. Others reached this sector of the galaxy by more solitary means, joining the parade of a billion singular celestial wanderers in their graceful pavane around the galactic core. Each member holds their own intimate history to divulge under scrutiny, like individual droplets in a great sea of many, individual triumphs and tragedies unfolding across the scope of time itself. Of all the black holes and other objects, profound mysteries that human knowledge seeks to uncover, none compare to grasping the utterly incomprehensible beginning of everything in the cosmic dawn. Through ingenious observation and theory building, physics has managed to reconstruct the history of the universe back to the briefest sliver of a second after its birth in the Big Bang almost 14 billion years ago. But the exact origin itself and what may have preceded it remain shrouded in impenetrable uncertainty, posing the ultimate challenge to science and imagination. The observational pillar supporting the Big Bang model arises from the clear expansion seen in the universe on the largest scales, implying everything emerged from a hot dense state in the distant past. But extrapolating backward, the expansion suggests an initial point of infinite density that physics cannot meaningfully describe. All our theories break down irreconcilably when stretched to their primordial singularity. The beginning appears forever out of reach. Attempts like the bouncing cosmology theory tried to